a DTrace provider for the Bourne shell because it's another language, and it would be nice because DTrace can see all languages to start with, right? DTrace has visibility to the Bourne shell in a raw form, so you'd be looking at the raw Bourne shell functions. The idea of a provider is to make it easier, so you don't have to understand the Bourne shell kernel, the Bourne shell engine, but you're able to do. I forget, what probes did you add?
I'm kind of going to remember now. Things like function entry, exit, variable assignments. When we go off and do fork execs, which was particularly interesting to try and hack in there. Finding all sorts of interesting things about the Bourne shell in there that I didn't know. We also had to hack in, make it remember line numbering and things like that, so we get another probe fire for each line you go through. And things like that.
And how long did it take you, Alan?
It was only about a day, I think, over a weekend or something like that.
It was a day, and Alan hadn't, you hadn't spent a long time in the Bourne shell code before.
No.
So going from, all right, I need to learn the Bourne shell engine, to actually having a working provider is a day, learning it. It's actually, if you want to write a provider for a language, and please do, it's lots of fun. A certain version of fun that kernel engineers might like, or other engineers. It's easy because you can write frequency counts, which I mentioned is a very crucial part of DTrace, very useful. You can write your own piece of software, run it, like say I'm writing a provider for Perl. I can write my own subroutine, run it some prime number of times, like 17, and then I can use DTrace to just frequency count the engine and says, what happened 17 times? And that will give me a very rapid way of understanding how the engine works, because something executed that subroutine 17 times. So DTrace lets you actually. I wrote the DTrace JavaScript provider initially, and that was put back into Firefox 3. So that's part of libmos.js. Didn't take me a day. It took me longer than that. Took me about 2 weeks. And I'd never seen libmos.js, the Mozilla source before. But again, just doing some experiments, running some simple hello world JavaScript programs, seeing how it ticked, I was able to come up with a nice JavaScript provider in about a couple of weeks. And that's now part of Firefox.
That being said, while it took me that long to actually put that in there, once you've actually got those probes into something like the shell, you get somebody like Brendan comes along, and within about 6 hours of me showing it, giving him a copy of the binary, we had about half a dozen different complex scripts looking at things in the Bourne shell.
Yeah. So did you have a language in particular?
It's a bit embarrassing.
A bit embarrassing. Come and tell me it's COBOL. Basic? Oh, no.
Haskell. It's OCaml.
It's what, sir?
Yeah, exactly.
That's why it's embarrassing. OCaml. 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 Okay. OCaml. I haven't heard of a provider being written for one, so I think it's there for the taking. So take a swing. It can be interesting. So.
New question. There we go. Thanks. So there's demand for generic introspection on what a database server is doing and what's going on during query execution. The trick is that there is demand for this, of course, without affecting performance and cross-platform. So my great unified theory would love to be basically call back to DTrace and get it to patch the binary at runtime. So it's basically zero effort when you're not running it, and then hooking into the bits, one up metrics and pull metrics out to the user over a SQL interface. There is a problem. It's only Solaris 10, so it's.
What's the question?
When can we actually solve the problem and have it cross-platform and be useful for doing applications? Please go back and test the people.
That's mostly a licensing sort of issue, and so it's not really relevant for the panel. Let's try and keep it technical.
It's a big technical problem. It means basically I get to re-implement the same thing. And it's kind of like, that's really annoying to me.
Maybe try and keep the questions technical, because we've got good tech guys here, and leave the policy and licensing for people that are into that.
I can answer the technical side of it, and I'll hand the mic if anyone can help. So detracing a database is really interesting because you have things like query start and end and execution. You can see the database pipeline as it executes things, authentication, and there has been some database providers written for MySQL and Postgres. They're really, really cool. In terms of performance, It depends, and this is just a generic question for DTrace, how frequently does something run? So if it runs 1,000 times a second or less, DTrace probably isn't going to make any negligible difference. If you have something that's running at, say, 100,000 times a second, then the few nanosecond or instructions that DTrace adds multiplies up. And so there are instances where a customer has a massive database and DTracing every single query will noticeably slow it down. So it's about frequency and scale, although in those scenarios you remember that DTrace is something that you don't leave on 24/7. You switch it on, you gather a minute of data.
Profile this query and then you can go down. The other is that people running otherwise, you have to write all your own code to do it because you can't use DTrace.
Yep.
Is to go and say, well, what mutex are taking the server, what blocks are accessed, what IO requests are due, what do we get from the buffer pool, what do we have to ask the OS for, which you could do like function inserting into DTrace if you're running a Solaris, but people aren't. So we have to write it all ourselves, which has performance impact, much more so than DTrace, which is why I would like to use it.
So yeah, if you're an application developer and you'd like to use DTrace, but you're thinking, oh, it's only Solaris or Mac OS X, don't let that stop you, because you can use ifdefs, which you mentioned earlier. You can put in some ifdefs in there.
But it's not a generic solution, which means that no one who deploys it can use it.
But there's not a technical reason for that at this point. There's licensing and IP related issues, and they're probably more significant than the just pure technical barriers.
That's the really annoying thing of that. Even if there was nothing else, just being able to
wait a few months in historical.
Sorry. Yeah, that's a big block for us. It means basically even just putting in the basic probes is like a next to no gain, and so it gets really low down. So it's a technology adopting barrier.
We move on to our next question. Up the back.
Would it be okay if I emit an advisory rather than a question? You may choose to comment.
Sure.
It's just I noticed a lot of Mac people in the audience. I mean, we may actually develop like I do for Linux, but I actually do it on a Mac, and DTrace is interesting on a Mac as well. I've had shown to me by other developers who are a bit more into it, using DTrace, that the implementation on a Mac has some limitations in that you will lose samples whenever you happen to be running certain pieces of software in the background due to DRM.
Oh, this is your favourite one, Brendan?
Yes, and so there are public examples of this on blog entries. When Apple first implemented DTrace for getting around DRM, it would not instrument some things like iTunes. But I believe, I can't confirm, but I believe they fixed that and DTrace now works fine. So the previous problem is if you profiled it, it would be as though you're missing samples, because when the DRM code was running, Apple would not let you instrument it.
You just blanket, it blocked all instrumentation period.
Yeah, it blocked all the instrumentation period. I heard that got fixed. I haven't checked it on the latest Mac OS X.
I believe it has. As of 10.5.6, which was actually one minor release ago, it hadn't been fixed.
Okay, so you probably know better than I do, so that's unfortunate. If you're tracing an application that has DRM for some reason, then you may hit the brick wall where Apple doesn't let you do that.
It's not about tracing the DRM application, it's that you're tracing something else
Yeah,
that you're
right.
interested in.
So the solution is don't run iTunes while
Yeah,
using
basically,
DTrace.
anything that might be a background process that might be Apple specific.
Yeah, and it is annoying because you may be tracing application X, and something like iTunes just happens to be interfering with it, and if it's missing the samples, it's kind of hard to troubleshoot. So anyway, I understand the issue. There's still lots of cool things you can do with DTrace on Mac OS X, whether we get that policy lifted or not.
Yeah, thanks. The purpose of that was just that if you see this sort of stuff, you don't understand what's going on, and that's probably what it is.
Yep.
Next question.
Given that DTrace hooks in at quite a low level, is there any other protection to actually protect, say, a developer writes their own DTrace probe to actually sort of prevent that from panicking the system? Or is there any other sort of test suites that developers can use to produce high quality probes themselves to prevent that from happening?
Cool. It's a good question, and I'll give Max or another person a chance. Is it not Max? Kevin? Yeah, I'll just repeat the question first, and that is, if developers write their own DTrace scripts, is there any protection for them panicking the system or doing something that they shouldn't. So there are DTrace privileges. So Solaris has implemented them. I'd have to check if they exist on Mac OS X. And so you can give non-root users different levels of privilege with DTrace so that they can access what they need to do. So that's part of answering your question. Another part is DTrace is designed to be safe. So if you use it, it's not supposed to panic the system anyway. Also, if you do something by mistake and you instrument too much stuff, DTrace has heartbeats so that it realizes that it's slow. Because I can instrument every function in the kernel, right? That's going to slow the system down because I probably don't need to instrument every function in the kernel. I can also instrument every instruction in every function in a userland process, which just gets insane. That's millions of probes, and that will slow it down. DTrace realizes that it's slowing things down, it has a heartbeat, and it will self-abort. So the system will run slowly for a few seconds while DTrace realizes it's the culprit, and then it will suicide. So DTrace is absolutely from the start to the end been designed for production server use, and we couldn't go and run it on high-end crucial applications without protections like this.
There's only the destructive flag -W if you realize.
That's right. So as Gavin said, that you can switch on a destructive flag -W, and that lets you do things like raise random signals to processors. You can overwrite memory in userland. I was running a destructive script earlier that Andre wanted me to do a destructive example. That was the noisy typewriter on the keyboard. To actually execute a process from within DTrace, that's considered a destructive action, because it's not just reading something, it's actually going in and doing something. So you can't run destructive things by default. That's a special privilege. So there are lots of protections in there. But DTrace, it shouldn't panic your system.
Unless you tell it to.
Unless you tell it to, and you can tell it to, and that can be useful. And it shouldn't do anything naughty, like slow the system down for too long, because it will self-abort. Maybe, and I have heard customers say that this is a legitimate worry, if they give all developers access to DTrace, and like heavyweight access to DTrace, maybe they can DTrace system calls and look at contents that they normally shouldn't, if it's a very secure environment. And it's just the same as like if you give someone access to TCP dump or snoop, is that allowed? Same sort of policies. So I have heard that raised before.
Following you on that, DTrace by default is read only. You're reading it, you can't write things into it. Read only.
Yeah, that's the best way to describe it. So by default, DTrace is in read-only mode. So you look at the system and you don't change it. And to actually change the system, you have to enable a special flag called destructive.
Yep.
How do you place a probe at the instruction level?
How do you place a probe at the instruction level? So with the PID provider, I can... Do you mean userland or kernel to start with? Don't say kernel. So with userland, do I still have a projector up? Can I have a projector up quickly?
Do you want to work that one?
Yeah, but it lets you actually do it on an instruction level.
Yeah, but it still just replaces the instruction.
Kind of cool for finding hot loops. Oh, you probably. So
No, that picked up the room. It's on quite high.
Yeah, I'm just running so for example, KCA password, go instead, in fact I'll get settings to do that directly. Most of your ratings use block, I think you will know the settings as well. This is just an example for me to pick away at using DTrace. Hit all the time, next using the PID provider. I'll actually do everything. So looking at everything that I can for this set command. My full MacBook is thinking for a while, so it's my actually DTrace. STR.
Cat instead of stag.
Maybe you haven't done this on macro 61. Maybe just go through.
Running on systems.
I get to a stars box. Right? I'm going to think of these guys to answer another question while I say
Over there.
What's the relationship between a DTrace provider and publicly exported symbols and symbols that are defined by header files and internal structures?
There's no real relationship, is there?
Well,
You've got the CTF.
BT and CTO, yeah.
So the question is, what's the relationship between symbols that are defined in the name table of an executable, those that are exported via the header file? Is that it?
Sure.
Yeah, okay. And I don't think there's any... the DTrace gets what symbols it's able to export, say, for function boundary tracing out of the elf name table of the executable. It's not consulting your header file or your public interface at all. It's able to access all of those. If you really wanted to concentrate only on your sort of key interface definition functions, then you need to teach it what those are, and what you typically do there is add the SDT probes, the static DTrace probes. So in those functions you put in the SDT macros, and there you get your entry exit. So if it was like for instance, the database thing where you've got transaction begin and end, you'd go and put a static probe in there. Or alternatively go and write a grand big script that uses the function boundary tracing and explicitly give it those members. And then also, as Alan said, DTrace has got access to all the CTF info, which is the sort of common type format which records all the data structures that are defined from your header files. So it knows the layout of all those data structures. But I don't think that was a question.
Oh, that was related. Yeah. Thank you.
Just before I call the next question, I noticed a few people have disappeared. We aren't going to run that much longer, so unless you actually have to make a flight, if you could bear with us a little bit longer, that would be great. But, next question. In the back corner.
You might not be the right people to answer, but it's still something. So, I've been using DTrace for quite a long time, and I've been looking at ProView, IBM's DTrace clone, and they actually have some features that I actually really like. Particularly since I'm working mostly with application developers, the facility to be able to get user-level application variables out from ProView easily. Whereas with DTrace, it's kind of magic with MVD to get the stuff out. Any plans of adding similar functionality?
That's more a question for Brendan,
really.
really.
Possible to add?
What is he talking about? Basically CTO.
Or should I ask?
That's something I've seen requested a few times. Effectively, if you're looking at anything in the kernel, you've got the CTF information, gives you that, you can put it up by variable name. If you're doing it in userland, you need to go to greater lengths to dig it out. You can copy things out of userland. It's a bit hit and miss because if it's not currently mapped in memory, DTrace doesn't have side effects, so it won't be able to retrieve it. But it's not able to access those symbols at the moment. I'm not aware of any work ongoing to address that.
I think it would be okay if you've got an error position, if that was the mentioned that variable was not available on the card. So at least we get the person
Right. Question is, Amy accessing userland variables.
Okay, accessing userland variables by symbol name, that's difficult because We don't have all the stuff done for CTA, but how I usually do it is I try to find some functions that touch that variable and hook up it that way. And so
That's usually how I do it. I usually get that. Or I stop the process at assembly and I get the symbol, average the symbol that I use for here. But most of the people I work with are application developers, and that's something I get a lot of times when I ask this question of can I do this? That is something they really like. And ProView does it very, very elegantly.
okay, well, it's if there's a big need for it, we're always adding and improving DTrace. So the question is really, I can pull out kernel variables very easily. I'd like to do the same for user land, like random applications. The current way to do it is you DTrace, say, a function entry that touches the variable and that gives it to you. The second way to do it, and I'm sure there's more than two ways, the second way to do it is you add static probes and recompile the application. And then you can throw it whenever you want, which is ideal as well.
So what about being able to use a debug build of a binary, something you build with SG, which puts in a alter, I guess is a dwarf header, I don't know, but all that information is in there so that you can use the ball debugging in GDB or DBX.
Yeah.
It seems like if you had a build with that binary, I mean, it doesn't require recompiling the binary, but at least you're not touching the source.
Okay. If you just touch the symbol table.
So what you can do,
Maybe something.
and Gary just reminded me of a third way, like I said, there's still lots. You can go to a debugger. If the symbol information is still there, find the memory address of the variable you're interested in, and then you can use DTrace to copy in function, destructive. Is it destructive? Copy. No, it's non-destructive.
It's non-destructive.
Non-destructive, and just give it the memory address and pull it in that way. So you can run a debugger to help finish writing the script to pull in those variables in. So that works as well. It's not as convenient. So the question is really when it's going to be easier. And I guess that's the
Is there an RFP for that?
there might be. I have to change this RFP for that. But there's plenty of ways to do it. We just wanted an easy way.
My comment was, it just seemed like whether or not it's implemented today, it should be possible to extract that symbolic information in the same way that GDB does. You know.
Yeah, it should be possible to extract the
RFP
symbol
for the PID
information.
provider.
It just hasn't been done.
Over there. I'm just thinking about the future of uses of DTrace. Have you thought about, say, using Doxygen to generate DTrace scripts from your source code so that you can instrument it at the time you're actually writing it, and thereby give your names to your variables or whatever else you need to do? Maybe check pre and post conditions on a particular API, things like that.
No, I certainly haven't thought about anything.
I don't think any of us
Something that's kind of going
have thought about it.
You want something that automatically generates scripts.
Generate scripts from your code. Or instrument a new language, you might be able to use, say, YAC or something that has a parser and just generate a specific, when it understands the semantics of the language, generate the DTrace script that says this is a form, it's not a function.
I don't know that it would buy you anything. You want something that will generate a script to trace the code.
I'm just wondering what people have thought about. Are these things that people have thought about? I mean, when you're writing code, you know what it's going to look like. You know how it's used, you know the pre and post conditions.
So for your shell example, you go to the YAC index.
Really understands what that goes about.
And stuff there.
And if you put that in a provider in DTrace, you can make that usable for other people as well.
Yeah, that's the point of providers.
Yeah, but yeah, I don't see why you would automatically generate a script from it though. I mean, you could just trace everything or just trace entry and return to functions, and I think that if you already understand what you're looking at, you wouldn't bother running DTrace on it in the first place.
I guess you're looking at it as post-analysis. I'm sort of thinking about other uses of DTrace. Say, pre and post conditions are sort of critical things to understand when you're developing the product.
You're looking at software testing?
Yeah, software testing. If you run a regression
Testing based on specification type stuff.
You've got
Yeah?
instrumented
Yeah,
figures
okay,
and actually
okay.
run your regression test.
Yeah.
You can check those.
So there's already something to do this that doesn't use DTrace, which is a source. And
Yeah.
actually the reason why I was raising my hand is, it seems like here is an example where actually having knowledge of the source code on a binary, where you're not going to necessarily recompile the code, but you had an assertion in the source code. So you could if you could basically process, have the two of these side by side, you can process a script that basically injects an assertion into a binary using a DTrace script, looking at the corresponding source code.
Do it by default.
So it would be like a stealth way to insert an assertion, and maybe just literally parsing the assert macro. Another idea would be to take those to have a compile flag that allows you to insert instead of the assertion, actually insert an SDT program.
Yeah, that's a great idea. Yeah.
Do that for the release builds rather than nothing.
Do you want to run your example now, Brendan?
Sure.
That's a good
Just
idea.
to answer the previous question before.
So they're going to compile another.
And the question was, previously, just a few short demos I did was looking at a system call and then looking at into the terminal. This is more interesting. The big provider, I'm looking at a function. The question was, can I look at individual instructions? So this is strlen.
Let me turn that off.
So this is strlen, and I'm just running it through send. If I stop listing it, so here I can see the entry of strlen as it's been executed. If I take off the name entry, it's actually going to trace every instruction in strlen, because this now becomes a wildcard. So now I can see strlen, so entry just says I've begun this function. I'm now running instruction 0 for AD, 10, 14, and so on. If I want to just look at one in particular, I can, that's the name of the probe. So here I only looked at strlen instruction 17. And to find out what that was, I could just, I'm on a MacBook.
But further than that, you can actually look for your hotspots by aggregating on your probe func.
Just like profile.
Yeah.
So
Except it's more accurate than profiling. Than using a profile.
Yeah. To find out what's 17, I use a debugger like everybody and tell me what it was. So that's fine. So doing that from user lens really easy. And just while I've got that on the screen, I'll just do this. What do we strlen? strlen takes the pointer to the string as arg0. No. Alright. That's what says it's running strlen on. If I do strlen on
A whole lot of LC stuff.
So I'm actually digging, like as data is running, as it's calling strlen, I'm dragging out the string. It's calling strlen on. So it's kind of interesting. You can see how programs think just by thinking of it.
So the instruction provider, can you get other information from like what CPU instruction it is and maybe what memory accesses it might do? So you could then try and do some logic on the memory accesses, for example, keep track of what is valid and implement the algorithm in DTrace.
Memory accesses and to see what is valid. So with each instruction, there is a collection of variables that point to the registers, the CPU registers. What's valid? Do you mean like if you do
basically to say this instruction is going to be executed, what memory accesses does it do and what time. So you could then write a script that maintains something that keeps track of your malloc call.
I'll use decode the instruction to figure out which register is.
Yeah.
And
so it doesn't provide that currently, I guess.
Like tracing the
one of the
code.
things to bear in mind, one of the reasons why we say don't rely on DTrace for security is under periods of high load, DTrace will drop events.
Oh, this
in an application like that, you
No, this would
don't
not
really
be
want to
for one, this would be for development.
Seems to me we probably could have enough of the generate enough of the raw data here, maybe to do some post-processing to find that kind of stuff out.
Yeah, you could, doing it within DTrace might be hard, but just dump out what you can and post-processing.
Yeah, so Valkyrie does it at one time, like
Yeah.
going for each memory access of the instruction, going, has it been allocated, has it been written to, is it copied uninitialized data, and for each call going to do that as well. But that, it doesn't involve relating the entire.
Yeah, I'd take this with DTrace. But DTrace lets me look at, what's it called?
The trick would be to actually find out the mapping between what memory operations an instruction is, a particular instruction is doing, whether you have to write that for each CPU architecture. So it actually sits down in the process and forget what each instruction is doing. And
I think it's swing at it because DTrace, on slides at least, you get to look at the hat layer and the functions there. So when you have misses, TLB misses, you have some visibility into what the memory sources are.
So yeah, performance counting stuff as well in DTrace.
That's right, John has some performance counting stuff.
Yeah, I've done some of that integration stuff before.
That might be interesting. And Paul's second question, the first one was can I trace user land instructions? The second one was can I trace kernel land instructions? Not in the same way yet, but you can do things like aggregate kernel stacks here on tracing, profiling at 1,234 hertz, just an arbitrary number. And I'm frequency scanning kernel stack traces to see what my kernel is doing. And it's telling you which instructions are hot in the kernel. This kind of works. And it's giving me kernel instructions.
Yeah, but I can't get a probe on one leg of a conditional that's incorrectly executed pre-nap.
No, I can't take that and just do that in kernel yet.
That sounds promising.
Yeah.
That's about all we really have time for at this point.
An answer for the gentleman there.
Okay.
For the capital thing, according to Adam, the bug we were talking about is actually fixed. It's been fixed for over a year. And the second thing for instruction actions, if you want to do those, and if you're a system administrator, you don't want your developers to do instruction action, you can disable that on a system-wide basis from as a